Hey there, all you Malenki Malchicks on the YouTube. My name is Chili, and we are continuing on with the Intermediate Game Programming Tutorial Series, Lesson 20. This is the second part in my little two-parter on collision in a platformer engine. Got a little nice little background video with some ultra violence here to set the oh my god, oh, I knew that was coming, but it still gets me every time. That is horrible. Just want to set the tone for this lesson because it is going to be a major clusterfuck. And I figure this is kind of sets the tone for collisions. Anyways, enough of the video. Now to talk about my video. So I finished recording this lesson. It's going to be about, I guess, 3.5 hours, what I'm saying? I'm guessing 3.5 hours, so you've got a lot of tutorial ahead of you if you have the testicular fortitude to stick it out to the end. So just warning you now, for those of you who complain about long videos, you're going to get a super long video here. So, that being said, I think we can handle this situation as adults. All we got to do is find the pause button. It looks like this. It's a button like this here. And when you feel yourself, your body shutting down, your brain turning to mush in the onslaught of my word bombs, just push the pause button, take a little note of this number down here, and come back when you feel refreshed and ready for another dose of Chili's word magic. Getting some learnings here. So yeah, long video. Take breaks as necessary. I leave it to you. What else? Oh yeah, and it's kind of complicated, and maybe I didn't explain things too well in certain sections. I don't know. It was kind of a clusterfuck. But that being said, I'm not going to re-record it or anything unless I have a chorus of voices demanding another version of this video. But I really just want to move on here. I don't want to repeat myself over and over again. I don't got the time. Ain't nobody got time for that. So, that being said, if you don't understand things in the video, go to the forums and ask questions, and either myself or someone else knowledgeable on the forum will definitely get back to you there, and we can sort it all out together for our mutual understanding and so forth. So yeah, long video, pause the video, and hard videos, so ask questions. I think that's pretty much all I want to say. A lot of this video is some of this video, the part that's following this introduction, is actually something I recorded at the beginning of the last video, but I cut it out because it didn't make sense to put it in there. So that's coming up next, kind of like a mathematical theory kind of explanation on how we handle collision correction, and then we'll get right into the coding. And a lot of coding there will be, and debugging and derpery on my behalf. Some of it planned, some of it spontaneous derpery. You get a full bouquet. The Chili experience, as they say. So yeah, I don't know really what else I wanted to say here. Just, you get the video that I made, and then you get a long time ago, and then you get videos that I made just yesterday, and it's all edited together, and you watch it, and you learn, and if you have questions, you ask them on the forum, and yeah, that's it. So, good luck with the collision, because you are gonna need it. It might be a kind of a brain fuck. I don't know, maybe it's really easy, and I'm just overestimating it. But either way, you aren't gonna know until you watch the video and find out. And you can't watch the video until I stop blathering on here in the introduction. So I'm gonna stop right now. So, you got your collision detected. Now comes the fun part. What the fuck do you do about it? You've got these two rectangles chilling out in each other's space, getting all up in my grill. What are you going to do about it? Well, you could, let me just make a new layer here. I'm going to copy this layer. And I'm going to go blending options. Just blend that motherfucker down. 30%. Okay. So, let's say you've got the light colored rectangle is your last frame position, and the solid one is your new position after updating. And it's colliding with the blue. So what do you do about it? Well, obviously you want to move this rectangle, the red, or the red and the blue, or just the blue, depending on, depending on your mood at the time. But let's say the blue is going to stay where it is. We're just going to handle the red. All right? Easiest way to do this would be, I guess, just to go back to where you were. This could be achieved in a couple ways. Like if you have your velocity, just do the reverse of your update and revert back to your non-colliding position. And you could do that, but it would kind of suck, because let's say you've got your guy over here, and his movement speed will make him go here next frame. And then, oh, they're colliding, so revert. And then next frame he tries to move and then revert. So what happens is the player just sees these two blocks. He's trying to move right, but he sees these two blocks just kind of standing still here with this gap between them. They never touch. You can't make the PPs touch, and that is not a good situation. Or is it? But anyways, yeah, so reverting, rewinding is, it works, but it's got its flaws. So what if you wanted to make the PPs touch? How could you do that? Well, there's a couple of ways. I mean, just looking at this collision, like any random collision, looking at the red block and the blue block, you have no way of knowing where it came from. Like, it could have fallen down like this, in which case you would want to be able to, you'd want to put it here, right, to handle the collision. Or it could have come in from the side, in which case you want to be from here. It could have come in from the bottom, in which case it would have to block over here. Just looking at the two things alone, you can't really, you can't say. Now there's an approximation in which you take the penetration and you take the shallowest penetration. So, I mean, if you're kind of jumping here and you go like this, boop, it's probably not going to be, it's not going to be this one. It's going to be, you want to offset in the vertical direction, right? The shallowest one in that case. Or if you're walking in, you're walking up and you go like this, you're probably not going to want to offset this way. It's going to be the shallowest one. So it's possible for the player to fall really fast and go bam like this, in which case the penetration would be, you'd want to offset this way in the deepest penetration. But generally, you want to offset in your shallowest penetration direction. So you can compare, fuck that. Let's say you're coming in, you go like this. You can compare your X penetration to your Y penetration, pick the shallowest one, offset by that much, and you solve your problem. And that will give you the proper result in most situations, I would guess. But obviously there are some situations where it wouldn't work, especially kind of like corner cases, where if you're moving this, let's say you have a high, let me just, you're coming in at a, let's say you're coming in at a shallow angle here. Shallow angle, but you have a high horizontal velocity. You might come in like this, and Control Z. You might come in like this, which would technically mean you banged into the side, but because your shallowest penetration is in the horizontal, you'll end up like this. So shallowest penetration will give you bad results sometimes. Another way you could handle the collision handling, good job, is, it's another approximation, by the way, is you could separate your motion. What I mean by that is, first you move vertical, then you check for collisions, then you move horizontal, check for collisions. And if you had a collision in your horizontal, wait, I think I said that wrong. First move horizontal, check for collisions, then move vertical, check for collisions. If there was any collisions during that time, you want to revert back in that direction, the direction of motion. So let me just move this over here. So I mean, in this case, first move horizontal. So if you're moving this way, you move horizontal first, you check for collision, which is here like this, and you revert back here by the offset. And then you go vertical, and you do that, and you're done. Which would simulate you bang into the wall and then sliding down. Stop it. And again, that works. That'll probably work in most cases. But like, let's say you imagine you got a character and he's trying to jump up here, right? So you're gonna jump up like this, and then next frame maybe he'll go like this, and then you'll go down like this or something. I don't know, whatever. He's trying to jump up, and so you do your thing, and you're gonna first move horizontal, so you go bam, and then you revert this way, and then you go bam, you do your vertical, and yeah, you didn't quite make it. You banged into the wall, and now you're gonna fall down. So that would probably piss some people off playing the game if they couldn't jump over your fucking blocks because you got some janky stuff. Now remember, a single frame is only 1/60 of a second, so you're not going to be moving super far unless you're going really fast. So in most cases, these approximations would probably give you the right result. And even if they fucked up, it would be so close that the player wouldn't even really notice. They'd just be like, oh, I guess I missed that jump. But the fact of the matter is that they are not going to give you the correct answer all of the time. And as you know, Chile is a perfectionist, so we are going to look for a solution that will give us the correct answer. So, how do we do that? Well, that's where the fun comes in. That is where you may have to pause the video halfway through and shoot yourself in the face. But I don't recommend you do that. I recommend that you listen to me and, learn and shit. So, we've got, how am I going to set this up? We've got a collision situation here. And we want to determine whether we collide with the top or with the side. And once we determine that, that'll let us know whether we've got to offset this way or whether we've got to offset this way to correct the collision. Now, just looking at the trajectory here, we can see, we're colliding with the top. Now, how can we analyze that geometrically? Like this is kind of like an animation here, visualizing. How can we visualize it as a static picture? Because that's the first step in turning it into math. Well, let's do it like this, people. I kind of want to make a copy of this, and then I kind of want to hide the copy. Good. Now I want to go to this layer. So let's draw some lines here. We're going to draw lines of motion. Actually, we're only going to draw one line from this corner here to this corner here, because this corner and this corner are basically, they determine whether we're banging on this side, on the top, or on the side. So this is, pretend this is a straight line, and this would represent the motion of the bottom right corner of this red rectangle. Now, as you can see, the bottom right corner collides like this. So we're colliding with the top. And what we can say is basically if this line passes over this point on the the blue rectangle, the top left point of the blue rectangle. If the line passes over it, we're colliding with the top. On the other hand, let me just undo a bunch of shit here. And let me move other shit if I can. Let's go for this one now. We draw our line here, and we see it passes under the top left corner of the blue rectangle. And so that means we're gonna bang into the side of the rectangle. So you draw a line from your bottom right corner here of your start position to the bottom right corner of your finish position, and you check to see whether that line is passing over or under the top left corner of your target rectangle. And that's how you do it. Now in terms of math, you've got a point here, you've got a point here. That means you can find the equation of this line. Oops, wrong one. You can find the equation of this line. And once you have the equation of that line, you take the x value of this point, you plug it into the equation, you get the y value of this point. You test the y value of this versus the y value of this. If it's lower, you're under. If it's higher, you're over. I'm kind of getting shit mixed up here. I mean, if it's higher, you're under. If it's lower, you're over. That makes sense. You know what I'm talking about, because y goes in this direction. Y gets higher as you go down. It's fucked up on the screen, and we'll just have to deal with it. So that's how you do it mathematically. Now I'm going to show you how Chili did it, because Chili didn't actually figure it out this way. So how did Chili do it? It's kind of a weird thing, but I want to show you anyways, because I think showing you in a couple of different ways will make it easier for you guys to wrap your hand around this bullshit. Honestly, I don't know how hard it is, because I'm stuck inside my own head. But in case it is pretty hard, we're going to go over it a couple times here. I mean, this is the second time. I'm not going over it a third time. Fuck that shit. So, you've got your start position, and you've got your finish position, which is colliding. So how do we determine this shit? Well, I'm going to show you how Chili determined it. We basically look at two things. We look at our velocity. So that's Vx, Vy. Velocity determines the difference between the start and the finish positions of your moving object. And the other thing we look at is the penetration. Sounds kind of dirty. Px and fuck, I fucked that up. Let's try that again. Py and Px. So you got your velocity and you've got your penetration. Now, we've already looked at a situation where penetration was an issue, and that was in the shallowest test handling algorithm. Whereas if your y is your shallower one, then you're colliding on the top. If your x is shallower, you're colliding on the side. So now we're going to take that concept and we're going to add to it the velocity. So we're also going to take into consideration the speed you're moving to bring you to that situation of penetration. So how do we analyze this bullshit? Let me take this back a step here. Well, let's look at it, first of all, strictly from the point of view of velocity. So given a fixed penetration, let's move around our velocity and see what happens. So if our velocity, if our penetration is staying the same, to increase the velocity means you increase how far your previous position was, because it takes more velocity to get there. Remember, we're holding penetration constant and we're changing our velocity. So we'll start with a velocity Vx of 0. So if Vx is 0, obviously we cannot collide with the side, right? We're colliding with the top, because Vx is 0, we're not moving left or right. So that means we must be moving vertically to have collided. So Vx0 means definitely collided with the top. We increase the Vx a little bit. Now we're moving here. Let me draw my line here. Line goes over, so we're still colliding with the top. Let's move the Vx a little more over here. Draw our line. We're still barely going over the top. So this was a top collision. Increase Vx more. Draw our line. Draw our line better. And now we see we collided with the side. So this little experiment shows us bigger Vx gives us side collision. And by intuition, I'm going to say that bigger Vy will in turn give us top collision. The more Vy you have, the bigger chance of your collision being a top collision. And when you have 0 Vy, you can only have side collision because you're not moving up or down, you're just moving to the sides. So, bigger Vx will tend to give us a higher probability of having side collision. Now, let's hold, let's go back again. Oh, fuck you. Fuck you. I fucked it all up because I didn't put it on a different layer. Okay, so you guys don't need this, you don't need this note here. Chili says you don't need notes. So, I'm going to put that, actually, Chili says you need notes. Chili doesn't trust you to remember shit. So, big Vx is a side collision. Now let's explore keeping the velocity the same and only fucking around with the penetration. Still sounds dirty. So I'm gonna do that. And now, how am I gonna do this? I want to merge these two layers. Just want to do that. Merge layers. Yeah. Merge layers. Okay, good. Now, holding the velocity the same means that the relationship between the start and the finish are the same now, and we're only changing their relationship to the target rectangle. So let's start with very little top penetration. And as you can see here, that gives us a line here, which is way above this point, so top. So very little top penetration gives us top. And slightly more top than or slightly less top than top penetration than side penetration gives us a slight collision on the top. Basically just kind of nicks corners here. The corners nick each other. And again, if we go the other way, more side penetration, now we can see that our line is going underneath this point and we're banging to the side. And again, almost all side penetration, or almost all, vertical penetration, very little side penetration, will give us a definitive side collision. So this is basically the same as the rule we had before. And it is this. We say basically big px, big penetration in the x direction, big px will tend us to have top. So big Vx gives us side, whereas big px gives us top. And now I'm going to make a ratio here. And I just basically did this by more or less what I showed you guys, just looking at the diagrams of collision and intuiting a solution. And what it is this. So let's make a relationship to test whether we're colliding with the top. So we go top if, and we know that a big px will give us a high probability of top. So we're going to go px. But we also know that a big vx gives us the side. So px will make this term larger, but we're going to divide by vx, which will make this term smaller. So if px is very big, it's going to make this whole thing small, which is going to make it less chance of being larger than this term, which is py over vy. So you can see here a high penetration in x will make this bigger, giving it a bigger chance of being bigger than this one. And again, a low velocity x, we're not moving very much left or right, will give us a high probability of being top collision, right? Because if we're moving very fast to the right or left, chances are we're hitting the side of something. Whereas if we're going up and down, very little left and right, this goes small, which makes this thing bigger, right? A big Vx would make this whole term smaller, which would give it a bigger probability of being smaller than this one, falsifying this, making it side. So this is how I did it. It's kind of complicated unless you kind of intuit the ratios here. These ratios explain it, but you can do a simple thought experiment. Imagine again Vx is 0, so we're just moving horizontal vertical. Let's see if I can I can't do it. I'm gonna kill this one. You go dead now. Oh, fuck that. I didn't want to do that. I'm sorry. I apologize. I apologize profusely. That's what I get when I write shit on the wrong layers. But anyways, ignore this fucking thing here. Let's say we're moving only vertically. That means that Vx is 0. So if we're just moving vertical, we're sliding this guy down here. Bam. Obviously, we're colliding with the top. If you're only moving vertical, there's no way you're going to hit the side of anything. And if you're only moving vertical, Vx is 0, and you divide by 0, px over 0, anything divided by 0 is basically infinity, which is obviously going to be larger than whatever the fuck is over here. So in that case, if your Vx is 0, you're definitely going to get a top. And same with Vy. So there's a little thought experiment there for you guys to prove this thing. But it doesn't really prove it. I haven't proved this. I've only given you some evidence as to how this might be true, but this isn't a proof. Now what you can do is you can take that earlier situation we had with the straight line and the points and everything, and you can plug this equation into this, and you can prove this. And I have proved it, and it is true. That being said, I'm not going to prove it on here because it would just take too long, and it would probably bore the shit out of like 93% of you. And for the 7% of you who do give a shit, I recommend that you try to prove this relationship yourself. Prove this ratio comparison thing. And if you have done that, then give yourself a pat on the back. Or you can actually prove it on video and send me a link, and I will give you a pat on the back. No money though, just pats. Okay, so this is the relationship. Now there's only one more thing I want to do with it before we get into coding, and that is that we've got these dividing here, Vx and Vy. Vx and Vy can very conceivably be 0, especially Vx. If you're just falling down straight, your Vx is going to be 0. And in that case, you try to calculate this in the in code, and your computer is going to barf because you're getting a divide by 0, and it doesn't like that. Does not like to divide by 0. So what we're going to do here is we're going to do a little math happiness, which is, and actually it's funny because when I did this, when I did the first run through of the collision code, writing it on my own here, I used this exact thing the way it is, and I had to handle the problem of dividing by 0, and it was ugly. And then I thought to myself, maybe you should just stop being retarded, multiply both sides by vx, and multiply both sides by vy, and you get vx, here, vx here, and vy, and vy. These vy's cancel, these vx's cancel, and you get vy times px greater than vx times py. And this is the final relationship that we're going to use to test, to determine whether we're colliding with the top of something or the side. Now I've only actually shown this example here of coming at it from the top right, but it's very similar coming at it from other directions, and we will handle that when we get to the code. For the most part, this is how we do it. We only need two things. We need our velocity and our penetration, and from that we can figure out how to handle the collision. And obviously, I think I've explained this before, but if it's not completely obvious, once you determine if you're colliding with the side or the top, then you just take, for example, if you're colliding with the top, you take the penetration in the vertical direction and you offset it in the opposite direction here, so that you are no longer colliding and you're just resting very gently on the top, sitting pretty. Good stuff. So, fucking cold throat. Got a little bit of a throat bug, but we will soldier on after I drink some water. And yes. So, after that lengthy introduction to collision correction, let's do something completely different, because that's what we do. Well, not completely different, but I'm going to get you to, first of all, let's go to player sprite here. Let's change the Y position that we start off on. We'll go for 425. That's just a little cosmetic matter at the moment. It's going to let us start on the actual level of the platform. Yeah, like that. Actually, I want us to move over a little bit here. So let's go for 225. Let's see how that works out for us. That's good. Perfect. Okay. So now we've got our dude in a plausible start position. What else can we do? Well, what we're gonna do is I'm gonna ease you guys into this. We're not gonna do the full-blown collision correction in X and Y. We're gonna start off correcting the case when we're only moving to the left or right, when we're running, right? In that case, we know we're always going to be colliding with the side of something, so it makes it a lot simpler. So we'll go to player running here, and we're going to need to add a on collision event. But first of all, our on collision is kind of slipshod right now. Where is player? We want sprite state, I guess. Okay, so on collision, this is not what we want. What we're looking for is a constant rectf list. And of course we don't know what rectf list is because it is defined in, where was it? I think it was in tile, where tile map is. Yeah, it's defined here, which is stupid. I will admit this is stupid. We should define this where do you think we should define it? Perhaps where rectf is, because it's a list of rectfs. So we'll do that, copy that, put put this down here. Yeah. And that is good to go. Now we go back. Too far back. Good enough. And we see that RectF list is now fine and dandy. So we need to fix a couple of loose ends there. Obviously, jumping is going to be kind of messed up because that's totally different now. So we'll get rid of that. Yeah, we'll kill it for now. And oh wait, scratch that. We want to go to on collision. The definition. We'll delete that definition. Then we'll go back and delete the declaration. And one more thing, we want to go to game.go and get rid of this bullshit, because that no longer applies. Let's just try to build it now. See if it builds. And that's fine. Okay, so that is our collision all set up. Or sprite state. Here it is. So our collision is going to be based on a list of RectF objects. Now we want to override this function in player running. So we go down here. Actually, we'll go back. Back. Yeah. Copy this. Go forward. Paste it here. Get rid of that. And now we're ready to go to implementation file here. Oh, wait. I gotta go back. Back. Copy this. Forward. Paste it down here. Ugh. White space. And we want to get rid of the virtual. And we'll copy and paste a player running onto here, and we're all good to go. Okay, so how are we going to handle this? Well, it's quite simple. It's basically that stuff I explained to you, only way simpler. What we want to do is, obviously, if a rectangle is in our RectF list, then we are colliding with it. We can assume we are colliding. So now we have to decide whether we're colliding on the right side or the left side. And we make that decision based on our speed. If we're moving to the right, then that must mean we're colliding on our right side. And if we're moving to the left, we're colliding on our left side. So we'll do if core.vx greater than 0. And we'll do, what are we going to do? For RectF list iterator, not insert. Fuck you, man. Okay. I is equal to list.begin, comma, end is equal to list.end as long as I is not equal to the end I++. So there's how we iterate through our list of RectF objects. And for every one of these, we're going to do, let's see here. Let's do I. What are we going to do here? We want to modify our X position based on the amount of penetration. So penetration is equal to, if we're moving to the right, if we're colliding on the right, penetration is equal to sprite So core dot get crect dot right minus I pointer to left. That should give us our penetration if we're colliding on the right hand side. Let's just bring this up for those of you who aren't getting the picture here. We're moving to the right, so we're colliding like this. Penetration is sprite's right side minus the rectangle's left side. So that is our penetration, and what we want to do is we want to subtract x, so we go core.x minus and equals, we want to subtract that value from x. Now, one thing I like to do is if we hit something, we might as well set our velocity to 0, because that's generally what happens when you bang into a wall. You stop moving. You don't have to do this, but it's what I like to do. It prevents some janky things from happening later on. So yeah, and then we just do the same thing if core.vx is less than 0. I should put that 0.0f just because f. There we go. And we do much the same here. Except now here we want to increase core.vx, and here we're going to do I pointer to right and core.getCrect.left. We're switching it up a little bit. And we also set the velocity to 0. Now, here's a problem. This is underlined. It's saying we don't like list. What's the problem here? No suitable user-defined conversion from constant iterator to iterator is what it's saying here. Now, because this is a constant reference, we're not allowed to change anything in the list. But normal iterators are allowed to change things. So you're not allowed to get a normal iterator from a constant reference or a constant object. What you got to do is you got to do const iterator. Then it's fine. Just a little bit of trivia there for you. I probably spent like a good 5 minutes trying to figure out what the fuck was wrong with that. I was like, what the fuck? What's wrong with my list? You don't like my list? That's racism. So yeah. Build that. Okay, so it's so far so good. We've got our two cases moving right, moving left. Iterate through every one of the rectangles that we're colliding with and do our collision magics. So now what I want to do is actually implement this in the game. So I go to game, I go to go, and I basically want to do this stuff. So get my list first of all. A little copy paste, and then what? What's my sprite? Sprite is P, right, for player. Dot get state on collision list. And that should give us our collision detection in the horizontal. How's it going to look? Well, I'm going to try to move left. Watch me move left. Bam, bam, bam. Oh, can't move. Can't go that way though, but I can move. It's getting stuck here. Weird. For some reason, if I try to move left, I go right. And if I try to go right, I stand still. Now, that's kind of annoying because I was expecting it not to work, but I was expecting it to do the same thing in both directions, right? So if I try to move left, I go right. And if I try to move right, I was expecting it to go left, but instead it's just staying still. Whatever. Now the question is, can you guys figure out what the problem is? And it's not that difficult. So I'll let you, if you want to try to figure it out for yourself, pause the video. And if you don't want to figure it out for yourself, then just keep watching. Because the problem is, as you can see in here, we're colliding with these bottom rectangles. So whenever we move, it says, oh, you're colliding, and then it tries to set us back. So it says we're colliding with this one, and so it pushes us back to the next one, and the next one. So we're moving at a speed of one tile per frame. As for this one, I don't know why it's not going this way. I could step through everything and try to figure out why it's this. What am I looking for? What's the word I'm looking for? This asymmetric behavior is happening, but I don't care. I'm just gonna fix the problem and hope that bad things go away. So the problem is we're colliding with those bottom tiles. The solution: stop colliding with those bottom tiles. But here's the thing. Here's the thing, my friends. Let me show you the thing I'm talking about. Our collision detection and so forth, what it does, let's line this up nicely. We'll do it like this. Okay. So what we have is we get the index of the there's these 2 points here, right? Top left and bottom right. We get the index of the tile in which the top left is pointing. So that's the this were in the indices. This would be 0, 1, 2, 3. So it'd be 0, 1, 2. And we get the index of the top left, we get the index of the bottom right, and we loop through all of those tiles. And that works fine in most cases, except in the case of where we are. Oh shit, son, that wasn't good. Let's do this again. Let's not fuck our layers up here. 0, 0, 1, 2, 1, 2. Fuck all these other guys. They don't matter. Okay, so back to what I was saying before I was so rudely interrupted by myself. We that system works fine, except for when the corners are right on the borders between tiles. Let me show you how this works. So these positions are 25, 50, 25, 50. What we do is we take the coordinates of these points and we divide the x and y by the size of the tiles. So this one would be 25, 25. So 25 divided by 25 equals 1. So the index of the top left point is 1, 1, 1, which is right here. Let's get rid of that. Let's get rid of that. Skedaddle, skedaddle, skedaddle. This is going to be the death of me. 25, 50. I keep writing on the wrong layers and it's fucking me over. Okay. So the situation is, of course, 25 divided by 25 equals 1. Get that layer over there. Yeah. Nice. And that's a situation of 1, 1. Let's get me some different color here. Yeah, nice. A nice light shade of gray. Like that. So that's this tile. And that's good, right? Because if we're right on this tile, that's what we want to be colliding with. So that's the top left. What about the bottom right? Well, the bottom right is on 50. 50 divided by 50 is equal to 2. So the bottom right tells us that we're colliding with this one. And of course, we loop from right to left, top to bottom. So it's going to tell us we're colliding with these 4 rectangles. But we're actually only colliding with the 1, 1 rectangle, right? We don't want to include these rectangles. But that's what we get. Because that's the way the math works. You divide by the tile size and you're going to get the tile. Even if you're on the border, if you're on this border here between 2, you're going to get the one to the right. So you're on the border here, you get the one to the right. You get the one to the bottom. That's what you want. You don't want this one. You don't want this one. So it's good on this side. But on this side, the behavior is bad. We don't want this one. We don't want this one. We don't want this one. We don't want them. We do not want. So how do we solve it? Well, we could say, that's easy. That's easy, Chili. All you got to do is subtract 1 from your answer. So if you do this one, it's going to be 50 divided by 25, which is the tile size. You get 2. You minus 1, you're right here. You do this one, you minus 1, you're right here. That's fine. But try to this one then. You're doing 25 divided by 25. 1 minus 1 is 0. If you subtract 1 from your coordinate to index conversions, then you're going to get something like this, which is also stupid. It's just stupid in the other direction. So what we want to do is when we're doing we want different behavior, whether we're doing the top left or the bottom right. If we're doing the top left corner, we want it so that if it's on the line, if it's on the border, choose the one to the right or choose the one to the bottom. But if it's on the border in the bottom right side, we want to choose the one to the left or to the top, right? We don't want to be choosing the ones on the outside. We want to be choosing the ones on the inside. So we need 2 different conversion functions, one for the top left and one for the bottom right. So that's what we're going to do. That's how we do. So we got to go to tile here. I'm going to add some new functions. So get index x, get index y. Now these ones bias, they give us a bias to the right and to the bottom. So we'll do bias right, bias bottom. Now we need ones that give us biases to the left and to the top. So what we're going to do, copy that, paste it, we'll go bias left. Now we're going to need a little bit more fancier mathemahuzits here. So we'll do ix, we'll do int ix is equal to x, which is a float, divided by width, which is an int. That's an int, right? We'll just we'll convert that to int and divide it like that. Now here's where the magic happens. If ix times width, float, now we doing the opposite of what we did in the top, is equal to x, ix minus minus, return ix. So, do you get what we're doing here? It's not that difficult. We just divide, we do integer division, right? And then we reverse the operation. And if they're the same, then we know where they're on the line. Why do we know that? Well, because if they weren't the same, that means we must have lost something in the remainder. It wasn't it didn't divide perfectly. And if it didn't divide perfectly, it means it's not on the line. If it divides perfectly, then it's on the line. And if it divides perfectly, then that means that the reverse operation will give us the answer that we came in with. So yeah, I like it. I like my answer. Now we got to do the same thing for y. So we do copy, paste, stop it, bias top, and we're just going to copy this here, paste it here, and replace all these IXs with Ys and all these widths with height. Y. Good. Okay. Now we've got to change our tile map get C-rects. We've got to use these bias functions because these old ones don't exist anymore. So we do bias. So for the top left, we want to bias to the bottom. And so that's for the top. For the bottom, we want to bias to the top. So bias top. For the left, we want to bias to the right. Bias right. And for the right, we want to bias to the left. Bias left. And that, my friends, should be that. Now we should no longer be colliding with the rectangles on the bottom. And in fact, we are not colliding with those rectangles. Hallelujah! Bam. So you see, we can... whoa! What was that? Oh! So we have problems here where if we stop running, we drift into the wall. And that is because of our slide. So we can do this, we can stop running like this and then drift into the wall. And if we drift into the wall, of course, then if we try to move in the opposite direction, we're going to get pushed over here. So we've still got a little bit of work to do here. We have our work cut out for us, as they say, somewhere. Where to start? What problem should we start with? I say we should start with the obvious one, which is we need to add a handler to player standing as well, because in player standing the player can still move because of their drift. So we could add the exact same code to player standing, but I have a better idea. Let us what was I gonna do? Here we go. I was gonna draw shit, because that's how we do. So we have player... That color is weak sauce. Let us choose another. We've got... what do we got here? Sprite state. True. And then we've got player running and player standing, and they inherit from that. So we could implement that function in here and in here, but it's going to be exactly the same. So what else could we do? Well, we could do something a little neat here. We could say, well, player running and player standing, they have a kind of common feature. And that feature is that they're both states which only move horizontally. So we could do player moving horizontally, and then derive that from sprite state. And we put the function in here the collision function here, it's going to be inherited into these ones automatically. So we don't have to copy the same function in two different places. Now, this works because it's kind of logical to group these two together. They're very similar in many ways. They both have very similar movement. So I like it. I like grouping them together. I think we're going to do it. So, to do that, we need to add a new class. So we go project, add new item. We'll add a header file. Make sure to browse to the correct folder. I'm getting better at that, man. Fool me once, can't get fooled again. What was it? So we'll do player moving horizontally. That's pretty long, but it's okay. Sounds good to me. Wait, what? What happened? Okay, I think we're safe. Safe as houses. Player standing, player moving horizontally. Good. Let's copy player running. And let's, okay, we include sprite state. That's good. Player moving, whoops. Player moving horizontally. Public sprite state. That's good. Copy that. Put that there. Sprite core. We initialize the core there. We don't change anything here. What don't you like here? Provides no initializer for what? I don't understand. Control Z. Oh, I know. It's these ones here. We don't need that shit. That shit is bullshit. Don't want any of this crap except for on collision. We do want on collision because that's the one we're going to be, you know, doing it up. So now we need an implementation file. So we make a CPP file. And I hate typing. New item. That's that. That goes there. There you go. Swing your partner round and round. Include player moving horizontally. Alright, now we want, yes, we'll get rid of that, we'll do that, go back, put that in there, copy that, put that there, booyah. Okay, now all we gotta do is copy the stuff from player running, no, let's go player running. On collision. Copy this. Oh, cut that out. Delete the rest because we're not going to need it anymore. We'll go back. Ooh, put that there. And that should be that. Now we'll go to player running. We'll get rid of the on collision from here because we don't need it. And that, my friends, is that. Or is it? It probably is. Yeah, I think that's it, actually. Let's try to build. Because I'm probably wrong. There's probably stuff I forgot. Or maybe I didn't. Maybe I got it exactly right on the first try. So let's try gliding into the wall. It still works. Okay. What? 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 Okay, so we just managed to get rid of all of our collision. Not the desired effect. Let's fix our problems. Can you guys guess what I did wrong? Because I already know. I'll let you try to figure it out, but it's pretty simple. We didn't inherit player running from player moving horizontally. And of course we got to include that if we're going to actually use it. Include player moving horizontally. How's that? How you like me now? So I'm just going to go copy that. Then we're going to go to player standing. Put that in there. Copy that. Put that in there. Now we need to put this one in here. And player running. We'll put that in here too. And now we should have a pretty good stuff. Build. Okay, let's see if this works. So far so good, and we're not gliding into the walls. We're running up to them and stopping. Bam. Ah, so beautiful. So good. Lovely, lovely, lovely. Yeah, so that's collision. Just don't jump, because then we don't have any collision for jumping. When you jump, this happens. Whoa! And you're dead. So now there are other things we could fix in this situation. There are things that are not optimal. But you know what? Actually, there's one thing that might be a problem. That is a problem. And it doesn't happen all the time, it'll happen some of the time. So we have to fix this. Obviously, it's not good. It's not good when occasionally you just fly through walls in the opposite direction, which you intend to travel. Not usually the intended result. So, if you want a really good challenge, think of this as like homework. See, you guys want homework? I'm going to give you the thing that's better than homework. You get homework even before the video is over. Just pause the video and try to figure out why the fuck this is happening. Because it's not an easy one. But if you are not that intrepid, then I guess you just let me tell you why it's not working. Now the problem, as I see it, if my memory does serve me correctly, because I've gone through this and I've fixed this before. The problem with this is, where is it? Where's my update? Player running. I want my class view. It's much more useful to me. Player running on update. There we go. So we update our velocity. Then we update our position. Right. No, we update our position, then we update our velocity. Okay. What about for standing? Update position, update velocity. Trying trying to remember how this went, because it was a tricky little problem. The problem lies in the fact that player running, here we go, on, oh wait, we want player moving horizontally on collision. So we zero out the velocity if we are colliding, right? So velocity is zeroed out. Then let me go to let me get rid of this. I want more space to see. We go to game.go here. First we change our state based on our position. Right. Then we update our position. Then we do collision. Then we draw. So we're moving to the right. Nothing changes here. We update our position. We run into the wall. We are now penetrating into the wall. Then here we correct and set our velocity to 0. We go back here. We do nothing. We're still moving to the right. If we update here, our velocity is equal to 0. So we don't move to the right, but we up our velocity. Then here we haven't moved, so we don't collide. Then here, if we change our position at this very moment, our velocity is going to be moving to the right. But if we change our position, our speed is moving to the left. Then we update. When we update, first we change our position where we move to the right, but then we change our velocity. But because we were moving to the left state, our velocity will now move to the left. And then we update, we're colliding, our velocity is to the left, we get shot to the right. Does that make sense? I hope it makes sense to you guys. It sort of half makes sense to me. So let me just put it on a picture for you guys. We're colliding, we're moving, we collide. Our position is reset. Here, our velocity is set to 0. We're still holding the right button, by the way. So our velocity is now 0. Next frame, because our velocity is 0, we don't move in. We don't collide. But because we're holding right, our velocity is updated, and now our velocity is 1 or whatever, moving to the right. Then, next frame, we switch to moving to the left. Our velocity is still to the right, so first we update our position, we go in here. Then we update our velocity, and we're moving this way. So our velocity is this way, but we're in this collision state. But because our velocity is this way, the collision handler thinks we did something like this. We came in from this side and went BAM! So it pushes us back this way. This is what I think is happening. How to solve. What to do. Here's how we do. We go to our player running. And we go on update. Let's update our position after we update our velocity. This is how do. Then we go to, just to be, symmetrical, we go to player standing, we go on update. We do that. Update velocity before position. This will solve our problem. Now we no longer have that problem of jumping to the other side of the wall. There you go. Very simple fix, but it's a pretty hard problem to find. So for those of you who went through the trouble of trying to figure it out yourself, I salute you. Wow. By jumping off a cliff and killing myself. Break. Stop. Okay, so that is horizontal collision in a nutshell. That's all we got. That is all we need. Player running on update. Yeah, so I guess the next thing is to go into full-on collision in 2 axes, jumping collision as it were. But I think I'm going to stop the video here for a second and take a little break. Alright, that is it for the foreplay. Now let's get on to the main event. But before we move on, there's one thing that's been bothering me. I just want to fix it up. For that, I'm gonna have to do some splaining. There we go. So in the current situation, this isn't gonna work. I need a bigger thing. Ugh, screw you. Screw you, you and you. You two are the ones I want. If I can move it. There. Good. Alright, that's perfect. So in the current situation, we've got our dude, right? And he moves. And let's say that, for argument's sake, these 2 tiles are, say this is all solid tile. Can't pass through it. So you go and oh, I see what I did there. I totally fucked it up. Let's try that again without totally fucking it up. So again, here are our solid tiles. And we move. We collide with these ones. We get a list of the tiles we're colliding with. That list includes this tile here and this one here. So we do the collision for this one. We move back. And then we do the collision for this one. But the collision for this one, we don't have to do it because we've already been sorted by this one. And that case happens a lot. Another thing is, let's say we do the collision for one tile and it moves us back. Let's say we're colliding in like this. Like this, bam. I'm gonna say this one now is also solid for argument's sake. So we come in, you Dirk. Always the same tricks. There we go. Good enough. So we come in like this. We come in like this. Or whatever. I don't care. And we do our collision here, and it sets us back here. But now we're colliding with this one. But in our original collision detection, this wouldn't have been in the rect list. So by correcting one collision, we might create a new one. Now that opens a whole nasty can of worms and all sorts of nasty stuff. But the main thing that I want to get here is I don't like the way we handle things right now, where we send a list of rectangles and then we handle the collision correction for each rectangle. Because in general, usually handling one changes the whole system. It changes the game. It's a game changer. So what we're going to do is we're going to change how on collision works. We're going to go to sprite state here, and we're just going to do a rectf. No list, just a rectf. Now we go player moving horizontally. Also just a rectf in this one. And actually, we'll start it over here, like that. And now we don't need this. Or this. Or that. Or that. That's fine. It's not list anymore, it's now rect dot. Rect dot. Alright, so we do that. We rect. And to be completely thorough, we do it there. Alright, so that fixes the first problem. So now we're only handling single rectangles for collision. Now what we got to do is we'll create a function in tilemap called do collision, and we're gonna have what do we got here? What are we gonna use for our collision? Sprite? Yeah, I think sprite is fine. We'll do sprite s. And we'll go void tilemap do collision sprite s. How's that? You don't like sprite, do you? There you go. That'll fix that. Now what we want to do is do our collision with a sprite. So what we do is do the same thing we've been doing. We do rect f list get c rects s dot get c rect list. How's that? Do now here's the problem. I might be able to use a for loop. Alright, where was I? Before I was so rudely interrupted by pizza. I think I was doing, doing the collision. I was going to do collision, a collision function which takes a single sprite and does collision between the sprite and the tile map. It's getting hot in here. Let me take... Yeah. There we go. That's better. Okay. So, what we want is we want another function. I'm going to call this one get c rect list. I'm going to create another one. Get C-rect single bool and rect. So this function will return a list of C-rects, and this one will return a single one in here. And the return value here will be whether or not there was a rectangle found. So if no rectangles are found, this will be false. Alright, so get tile is undefined. It doesn't make any sense. C-rect single. Okay, I gotta go to tile map here. Get the list. Bool single there. That should take care of that problem. Now we got to change this one up to make it so that it only returns a single rectangle. So we do the same thing. We loop through all of our BS, but when we find a rectangle which is not passable, we go rect. Wait. How's that? That's better. So we set our rectangle there. Return true. Otherwise, if we didn't find any rectangles, return false. That'll be good. Now we don't need this list. Rect F rect. Get a single rect. While there is a rectangle that we're colliding with, get C rect rect. So while there is a rectangle to collide with, s dot get state dot what? Okay, that's fine. Dot. Why is that not working? On collision wrecked. Now I'm pissed off. Why don't you work? Incomplete type is okay. What about sprite state? How about that? That looks like that was the one. For some reason I needed to include sprite state. I'm not even gonna fucking... I don't care, man. Alright, so we do that. Now we've got to fix a couple of little errors. like this one here. We don't need this bullshit anymore. Let's try to fix that. Get C-rect. Get C-rect list. Let's try to build that again. Good. Now we're going to go up here and do our little thing here. Do our little sexy dance. And that is CPT. T dot do collision. P. We should be able to pass P because it's a kind of sprite. It's a player sprite. Fair enough. Now let's see if it works. And it looks like it works. Same as before. But it's more efficient and it'll work better for the next phase of our little operation here. I'm all phlegmy and stuff. All right. Now is the fun part. We're going to have to implement this bullshit here. So how do we go about it? Well, we've got a good framework set up now with this do collision function. We just got to follow it through. We've got to study it out. So we go to player jumping and we add a virtual void on collision constant rect f rect. Copy that. Go down here. We'll go player jumping. Here. Okay, so problem is, of course, that this little equation of ours here is kind of for the case when we're coming at it like this and we want to know if it's like this. But there's also cases where we're coming at it from the bottom, from the top or the bottom, and from the left side or the right side. So you can think of it, there's 4 cases corresponding to 2 directions in 2 axes. So let's see here. Well, let's just code the first case and then we'll figure it out later on as we go. So the first case is if core.vx is greater than 0 and core.vy is also greater than 0. In this case, we want to do what? So we're colliding with something. We know we're moving to the right and down. So first we want to decide whether we're colliding with the top or whether we're colliding with the side. So we calculate, where is it? We need to calculate our penetration, first of all. So float px is equal to let's let's get our sprite rectangle. So rect f s rect equal to core dot get crect srect dot right minus rect dot left. Float py penetration y is srect dot bottom minus rect dot top. I hope that's pretty clear. Now, here's where we decide. We do our deciding here. So we go if, let's look at my equation again there, vy times px. So if core dot vy times px is greater than core dot vx times py, then we're colliding with the top. Top collision. In which case, what? Well, if we're colliding with the top, we want to set core.vy equal to 0 because we've hit a horizontal surface, so our vertical velocity should be nullified. And we don't want to correct, so we do correction by going core.y, and we want to subtract minus and equals the penetration in the y direction. Well, that seems to me like that would be... but then we also want to change our state, because if we collide with the surface, we want to stop our jumping state, and we want to return to our... what state do we want to return to? Running or standing, depending on whether we're holding the key or not. So if what things do we have? If is moving, is boosting, is moving. If is moving, meaning that we're holding down a direction key in the direction of travel. I forget the names of my stuff. Transition. There we go. Transition to player running core. What else do we have? No, core. Else, transition to player standing. Player standing, player running. Okay, if we have the... Why is this not happy? Why are we not happy with this? No suitable conversion from player running to sprite state pointer. Yeah. That would be a problem now, wouldn't it? Alright, so top collision, if we're moving, yeah, okay, fine. Side collision. Core.vx equal to 0.0f. Core.x minus and equal to penetration in x. And here we do not transition, because if we hit the side of something, we're still going to fall. We're still going to be in the jumping state. It's just we're no longer moving horizontally. So that should solve this case. Let's try that out. I'm sure it won't go horribly wrong, will it? So we want to hit it and then quit it. No, we want to hit it, and we want to hit it where we're going down to the right. So we want to go like this. Bam. Perfect. Look at that. Was beautiful. Of course, we're not going to fall because there's nothing to make us fall once we hit that running state. But I wonder if I just jump like this. Yeah, it worked fine. This works fine, people. Horribly, horribly fine. Now, if I can hit it on the side there, on a falling trajectory, this is going to be hard. Yeah. Bah. Okay, that wasn't good. I think I broke it, people. Oh, I really broke it. I broke it hardcore. And now I can't do anything. Stop. Thank you. Okay, well, anyways, that was kind of good. I want to try that again, actually. I want to hit it on a downward trajectory, so I want to go. Ah, haha. I hit it on an upward trajectory, and that made my life difficult. Just give me what I want. Yeah. No. I'm pretty sure I hit it properly this time. Oh, but I'm moving the wrong direction, so that's no good. Yeah, that's fine. That was good. Stop hitting the ceiling. I'm not hitting the ceiling there. Yeah, it's fine. Hit the side. Ooh. Well, we got problems, and I'm not sure whether it's just because I haven't finished all these cases or whether one of my cases is fucked up, but let's continue. So we have the velocity is greater than 0, x is greater than 0, y is greater than 0. I mean, there's probably a nicer way of doing this, but I'm not going to do it the nice way. Because this way is going to be easier. And I don't want to spend like 2 more hours on this. Else if no, this ain't going to work either. Because there's cases where x or vx or vy is equal to 0. We gotta figure those out too. How do I want to solve this? Well, we'll start if x is greater than 0. Tabulate that. Then if coordinate vy is greater than 0, else all right. Yeah, that'll make that a little easier to read. That was the wrong one. Just adding some comments here for readability's sake. Put this one here. Copy that. Put that there. Okay. So here we do the same thing, but in this case, Vy is going to be 0, so no y velocity or negative. In such a case, we need to change our subtractor here. Py. This one can go outside here because it's going to be used in every single case. So we might as well just put it outside the loop here. So in this case, what do we got? Penetration x is the same, but the y one is now going to be here's a case where we're moving up, in which case it's going to be rect.bottom minus, that's the penetration value here. Now we want something like this again. Yeah. Now here's the problem. Vy has to be negated because our equation is assuming these are all positive numbers. But in this case, Vy is less than or equal to 0, so we have to negate it on this side. So we negate Vy. Then I have top collision. Vy, add by the penetration, because we're colliding with our sprite is hitting the bottom of something. The top of our sprite is hitting the bottom. So I want to move it down if there's a collision. So it is moving. Now we don't want to transition in this case to player running or anything. Yeah. Not needed. Uh-oh. Am I changing the wrong shit? I think I am changing the wrong shit here. Keep that there. Keep that like that. Keep that the same. There we go. I think my font size got smaller there for a second. Side collision. I think my copy and pasting just got all fucked up. Alright, so here, okay, I'm just going to undo a bunch of shit because I don't know what went wrong where. Okay, this is so far so good. Now we want to copy this bullshit here, and we want to paste it down here. Get rid of that. Alright, that's good. Good. Now here, we want to do that same stuff we did before, which is rect.bottom minus srect.top. Here we want to negate our velocity. So we make them all positive again. Again, we want to nullify our velocity here, but we want to add by the penetration. No transition here. Still falling if we hit the top of something. And if we hit the side, that's fine. And we're moving to the right, so we want to negate that. That's fine. Okay, that was good. Let's try this out. This should give us our cases for moving to the right, either going up or down. Either is fine. That's fine. Moving to the left, we should have, yeah, just a big stall, which is expected. I expect it to stall. A little exercise for you: if you don't understand why it is freezing up, then you might wanna study that out there. Okay, so now we want to do the same thing, except this time for when x is less than 0. Less than or equal to 0, I should say. Okay. So now if Vy is greater than 0, now here we have to change the Px because here Px is less than 0. So we want to do rect.right minus srect.left. And this one's the same, but we want to, I'll do it later. Now here, our Vx is going to be negative, so we have to undo that. Top collision Vy. This is all the Y stuff. This doesn't change. And yeah. That's fine. Side collision. We want to add Px. Here we do the same thing. We fix our x. Here we have to fix x and y. That's fine. Vx is plus and equals. All right. So that should be all of our cases all nicely tidied up. All right, that's good. That's good. That's good. That's fine. So far, so good, people. We're getting collision. This actually went smoother than I thought. I thought I'd fuck at least one thing up. Yeah, there we go. Bam. Notice how when we hit this, okay, yeah, there's a problem, of course, but we'll fix that later. That's a whole different bag of oats. Notice how when we hit the edge here, just when I'm jumping up, and if I hit the edge, if I graze a corner when I'm jumping up, it kind of nullifies our x velocity there. Bam. But our y still keeps going up. So that's the behavior that we want. So problem number 1 is we jump on a surface, then we run off the surface. We expect we should fall, but instead we remain walking, which is probably not what we want. It's probably not the desired effect. Bam. So how do we fix that? Well, the way I'm going to fix it is I'm going to give us a new message here, a new event. So we'll go to player sprite state. I'm going to go virtual void on free fall or on unsupported. So this little event will be issued when we do a check and we determine that our sprite is not standing on anything. It'll get the event message that, oh, you're not standing on anything, you should be probably falling right about now. So I'm pretty sure we could probably handle this one in moving horizontally. We don't have to handle it in running and standing separately. So we'll do virtual void on unsupported, although we might have to do it separately. Yeah, because player jumping has an is moving thing here. And that is moving can only be determined from running. Yeah. Oh well, we can't do it in one fell swoop here in the parent class. You have to move down to the child classes. Do it individually, unfortunately. So player running. Virtual void on unsupported. Void player running on unsupported. So if we are running and we determine that we are not standing on anything anymore, we should transition. Here's the problem though. Player jumping will initialize our velocity to negative. Yeah, that's a problem. Bool is jumping has jumped equal to true. Where's the thing where we change the sequence for rising and falling? Kind of interested in that now. On update. Here it is. It's in on update. All right. If has jumped, set Vy equal to negative blah. Otherwise, leave Vy exactly the way it is. There's one way of solving this problem. I don't mind it. It's not incredibly ugly. And by putting this default value here, I don't have to go back and change all my old code. It still works the way it does with 2 parameters, which is a nice bonus if you ask me. Now, let's go back to what I was doing before I was so rudely interrupted by myself. Transition, player jumping, false. We're jumping, but we have not jumped, which means we must have fallen. I might want to rename player jumping to player free fall or player parabolic or something stupid like that, but I'm not going to. This video is getting long enough as it is. So if we're unsupported, we transition. And I think we should do the same thing for player standing. Virtual void on unsupported. We'll go to update. Paste that first. Copy this. Paste it. And here we also transition new player jumping core false false. There. How do you like them apples? So it's very simple actually in the player standing and jumping. It's just now we have to actually create something to trigger that event. That's the tricky part. So tile map. We'll have to do void do support. Sounds good to me. Sprite and S. There we go. I'm gonna take this one to the other side. Break on through to the other side. Tile map do support. My boy's gotta have a home. Now, here's where it gets a little sticky because we need to get collision rect list. We need a new function here to get us a list of tiles that we're standing on, or to at least run through the tiles that are directly below and see if any of them are solid. So what we want to do is we're going to loop through the X's here. Okay, here we go. Int IY is equal to this. Wait, what? Yeah. I'm gonna get this one. We're gonna go S. Collision rectangle. Rect F crect is equal to S dot get crect. That works fine. Then we do this. We get our Y. We get our bottom rank of rectangles here. We subtract 1. That gets us 1 below our bottom rank. Then we do this. And this will let us loop through all of the rectangles which are below our sprite. First thing we're going to do is we're going to check to make sure we are So we're going to loop through each one of these, check if it's passable. If it is passable, if it's not passable, meaning it's solid. We have a tile below us that is solid. If get tile gives us a tile Hmm. What do we got? Get C-rect. Okay, that's good. That should be fine. So we get our tile. If T is not passable, and T pointer to get C-rect dot top is equal to C-rect dot bottom. So if our bottom is directly touching the top of this rectangle. Wait, why don't you like C-rect now? Pointer to function type. What's this one? Too few arguments in. Get C-rect is a static thing. Well, looks like we can't save a little bit of processing power here. I take it all back. We go tile, pointer to get C-rect. And here we have y dot top rect f c-rect dot bottom. Okay, not a function. Okay, so if that tile is passable, and yeah, it seems good to me. So if it's solid and we're standing directly on top of it, then we want to return. We're done. We are supported by a single tile. However, if that doesn't happen, we continue to loop through. And if we get to the end and we're not supported by any tile whatsoever, we go s dot get state dot on unsupported. So we return prematurely whenever we find at least one supporting tile. But if no supporting tiles are found, we return, we call unsupported, and then we return. It seems like a good old algorithm. No errors there. Why do I have the feeling this is going to be horrible? We want to go to game.cpp. So we do our collision, and T do support. So we do our input, update, collision, support. Seems good to me. I have no idea. But it builds at least. Oh, that doesn't look good at all. That looks dumb. That looks really dumb. And we can't jump either. Whoa. Whoa there, son. Whoa, giddy up. Okay, so looks like Chili has managed to fuck it up really hard here. That is retarded. I will admit freely that that is retarded. The question is, how do I fix this? So do support. I guess I want to just step through it and see what I'm doing that is incredibly stupid. This was a case for the debugger if I ever saw one. And again, like I said, you can go ahead and try to figure this bullshit out for yourself if you want. It'll make you a better programmer and probably put chair on your hest or hair on your chest, whatever you prefer. Let's step in. So we get our rectangle. Bottom is 425. IY. Oh, okay. Probably this is the problem right here, considering that down is +1 and up is -1. I'm getting the index of... Yeah, I'm getting the index of the wrong tile. That would probably cause my problem right there. Good job, everybody. Working together, solving the problems. Let's try debug. Didn't help. Let's make sure I actually did it properly. Build. Okay, where was the thing I changed? It was in tile map. Yeah, I want to say it was in tile map. Here, +1. Bottom, +1. Here. Top. Bottom. I feel... Nope, still not working. Still not working. Alright. Back. I was hoping that would fix it, but looks like that was a little wishful thinking on my part. Why is this C-rect dot? Ugh. I should just do this. I should just bias it to the bottom. Of course, this has to be bottom. That's one of my problems here. Bottom. I could bias it to the bottom. I don't have to do +1. Yeah. Why wasn't I thinking that way before? Bias bottom. If not passable. I don't even think I need this test here. Do I need it? No, I don't. I'm gonna get rid of this. Wouldn't have hurt if I had it in there, but I don't think I need it because I'm biasing to the bottom, so this should work. Yeah, this is the ticket. Yes! Look at this. Look at us, we're running. This is practically fucking parkour here, man. Look at it, we're jumping on shit. We're falling off shit. It's making me so horny. Wait, what was that? That was weird. I thought I saw something weird happen there. I couldn't tell. Wow! Parkour! Jump off this wall! Jump on that one! Do it! Do it! Okay. Enough fucking around. A little bit more fucking around. Let's try to jump down here. Wah! Now, there should be a problem. If I'm not mistaken, there should still be a problem with this, because nothing ever goes right the first time, or the second time, or the third time. Okay, so if I jump here, it's not, no problem here. This is weird. Oh, I think I know why. If I jump like this, ha, wait, what? Ha, stop it. Oh no, what happened? Ah! I froze it. Okay, that's a problem. That wasn't the problem that I was talking about. That is a different problem. Well, geez. Okay, so this is not a problem apparently. This is fine. What if I do this? That's still fine. If I do that. If I do that. Oh! I think I did it. I think I found the thing I was looking for. See how when I run here and jump? Wait, I gotta do it right here. Bah. Bah. Stop it! Quit it! Well, I can't. Now I can't reproduce it. So I just sound like a crazy person. Okay, well here's a problem. Here's the thing I was kind of looking for. Look how when I jump and hit the wall here, if I jump to the right, banging my head, but I'm fine. I'm just moving, banging, moving. What if I move to the left? I'm getting like my head caught on the wall here. Watch. Sometimes I just get caught. That was fine. Those two are fine. What about this one? Caught. Not caught again. Can you see it? So sometimes if I jump up, I get my head caught on the wall. Now that should be happening when I jump up here as well. I should be like... There, I got caught. Did you see that? Did you see it? Ah. Now, getting caught falling... Now, sometimes it freaking crashes when I go down, and I don't understand that at all. But the getting caught jumping, I understand that perfectly. Now let me show you. If I can find the correct tab here. Quickly. The problem getting caught has to do with let's see here. See if I can get rid of a bunch of garbage. Oh, I don't want to get rid of that. Leave that. That's fine. Keep that. Get rid of that. Alright, let's see what I got here. How do I want to show this? Let's show it at the top here, because that was the one I could really reproduce the problem in easiest. So let's say I got a bunch of solid rectangles here. And my dude's moseying along and he jumps up. And his arc does a collision. And we're going to move to the left, because that's the left is when we get the problem. Jumps up, he does a collision here. Now depending on the angle of the collision and everything, if he hits the collision like this, let's say he hits it like this. First rectangle that we're going to process for the collision detection, we're going to have 3 rectangles. Let's say we get, no, we'll say we'll get 2. This one and this one. Let's just undo that. This one and this one. These 2 rectangles are going to be processed for collision. We start with this one. We do our test and everything, and we find that we collided with the side of it. Because of our trajectory, we actually ended up colliding with the side of this rectangle. So what we do is we reset it from here to here. And we nullify its horizontal velocity. Then we process the second one and we reset it down, and then we're fine. So we do the collision, everything is fine, but because we collided with the side of this one first, we ended up losing all of our horizontal velocity. So when we jump, we go like this. We should continue on like this, but instead we hit and then we go down like this. So instead of going like this, boing, we go like this, bam! And that's not good. And the same thing, I don't know why it wasn't working the other time, but the same thing should happen when we do a vertical jump, right? So say this is all collidable Ugh. Let's undo that. That's bullshit. Let's say that this stuff here is all like collidable tiles. Solid tiles, if you will. And then we go to jump. We jump up. But if our jump up like this happens to trigger so that we have collided with the bottom of this tile here, it's going to reset our position down. Then we'll collide with the side of this one and we'll be fine, but we'll lose all of our vertical velocity, so we'll bang our head prematurely and won't be able to make it all the way up. So that is one problem. And the way we can solve that, if you notice, this problem only happens when we're jumping in this direction. Bam, like this. If we jump in this direction, we're fine. Now, why is that? It's because if we jump in this direction, with our stuff, we're going to start here. We're never going to have a situation where we jump like this and it processes such that we collided with the side. It'll always be with the bottom in this way. Undo that. Undo all that garbage. Undo that, undo that, undo that. All right, there we go. Oh, you're breaking my heart here, Photoshop. So the problem is when we jump in this direction, we start with the tile that's leading into the jump. We have the problem of perhaps hitting the side of that tile. Whereas when we're jumping this direction, we start with the tile that's trailing in the jump, and we always hit the bottom. So what we could do is, depending on our jumping velocity here, if we're moving to the right, we could start our tile test as normal. We go in this direction. But if we're jumping to the left, we start in the opposite direction. We go in this way, this way, this way. And that'll solve that problem. And we could do the same for if we're moving up or down. So if we're moving up, we could start from the bottom. And if we did it that way, we'd start from the bottom. We'd be processed always to the side. And then afterwards, if there was a thing like if we had a collision at the top, we could also process that. But we would never have the problem if we start from the bottom, where we're jumping up and we hit the bottom of a tile and get bonked down and then to the side. So we modify the way we loop through the tiles depending on our velocities, X and Y velocities, and the directions that we loop through the tiles will prevent us from prematurely hitting corners of tiles that we should never be able to hit. Now, there are other better ways of solving this problem, but this one will work, and it will work within the code that we've already created. So that is what I plan on implementing. But I am a little concerned about that error that we get where our sprite just hangs, because that does not make any sense to me. So I want to see if I can recreate that. Because I don't see how. Assertion failed. So it looks like somehow we've managed to go off the screen there. X825, which is way more. Basically, we got pushed right off the screen. Now this problem is going to take a little bit of doing on my part, I think, to debug it. I'm not sure if I want to do that on camera or not. Let's see here. Player running. Probably happens during collision sometime. Problem is we can't reliably, we don't know how to trigger it, so when the program crashes, it's too late. It's already too late. We want to get it before it crashes, but we don't know how to trigger it. It's just simple falling is not the way. It doesn't seem to cause any problems. Ah, here we go. Here's one of the things that I don't like. And I bet you I know where this is. This is probably happening in the collision handler. Break. So where are we? Get index. Yeah, so we're in the collision handler here. Get rect single. We get a single rectangle here. So we get one rectangle here that is not passable. We return true. Left, right. Okay. See, this doesn't make any sense because this... Okay, that's the... Where's the sprites rectangle? Core X... Well, we'll see. We'll just step in here. Okay, yeah. Step out of that. Step over it. Step in. Player moving horizontally. That doesn't make any sense. Or does it? So it looks like we're falling, but we're actually in the player moving horizontally state. I don't get that. Okay. I think I have an idea now what's happening. But the vertical or the horizontal, we need... Okay, so this is a bad situation where... I see what the problem is here. Well, I don't like this situation here, because it can give us a situation where we're not doing anything. Let's get rid of that. See if we can get that same bug again. It might take a little bit of doing. But I got all the time in the world here. This could be a long video, people. A long video. We might have actually solved that bug there. Interesting. Whoa, did you see that? Because I think I saw it. Some weird shit. Oh, come on. Get out of here now. It's going crazy. Go crazy. Well, I have no idea. But fixing that one situation there. Whoa. Whoa. I think I saw something really crazy happen. Whoa. That was crazy. All right, so we got a bunch of crazy shit going on here. Yeah. Yeah, son. Yeah, son. Get some. Get some. Get some double jump shit going on here. If I can get like a... Wow. I don't even get why that would happen, but... So I think I figured out what's been causing the majority of the problems that I didn't anticipate. And that, my friends, is... Look at this. Oh, wait. I gotta put the focus to my window. Jumping. We're fine. We're jumping. Watch what happens if I try to jump and then change directions. Wait. No, it's not doing it. Of course. There, you see? Did you see that? Ah. Let me do it one more time. You fucking bastard. There. Did you see that? Did you see that? You see that? Yes. That, my friends, is weird behavior. And it's weird behavior that happens when we change directions. Now, do you remember when else that weird behavior and changing directions happened? Was when we had the... where is it? Player running here. Or player moving horizontally. On collision. No, that wasn't it. Player running. On update. Yeah. We had the VX before. We had the changing in the X before we changed the VX. So we had the position change before the velocity change, and that fucked with shit. And we changed that in running, and we changed that in standing, but we didn't change it in jumping because we weren't there yet. So let's go on player jumping. Update. And we'll move this code down here below the velocity shit. So this is all the velocity updating. Here's position. Here's animation. Now that one simple change should probably make the system work the way I expected it should have. So now we're getting that bumping the head behavior that I was expecting before, where we bump the head when we try to, if we're running right, and then we go like this, we'll bump our heads. Right, jump like that, try jumping, and then, yeah, there we go. And we shouldn't be able to do that weird thing where we teleport anymore. This should eliminate the teleporting problems. So that was just the same thing we had before, but I forgot to change the jumping, which is a good illustration of the rule as to why you shouldn't have the same code in a bunch of different places if you can avoid it. Having it in one place means when you change something, you don't have to remember to change it in a bunch of different places. So, here is our conundrum. And by conundrum, I don't mean conundrum. I just mean now we have to fix the problem that I was originally anticipating, which is this thing, which is really annoying. I mean, that will not do, obviously. And works fine when you're going in the right direction, like I stated in my... Wait, it doesn't. That's wrong. It works fine when you're falling down, right? Down is fine, but up, you bang your head. And in this one, right is fine, but left, you bang your head, if I can actually do it. Bang that head, you bastard. There you go, he did it at the end. Trust me, he bangs his head. If you don't believe me, try it yourself. So, how do we fix that is simple and a little complicated. We gotta go to do collision, maybe? No. So here's our get crect list. Get our list of collision rectangles. We don't need that one. We want to get crect single, but we want to loop through it in different directions depending on our velocity. So we'll get this here. We'll get that back there. Now, how to do this? This is gonna be complicated. My freaking head hurts. Because the start and the end and everything is gonna depend on... Alright. I'm going to change a few things here. So here's our loop. We go from the IY start to the end. Because I want to use the same loop in every single case. So I'm going to do this a little more trickily. I could just copy and paste this thing 4 times and different cases and bullshit switch things around, but I'm going to... You know what? Fuck it. Fuck it. Alright, let's go back. There we go. We're just going to do this. Wait. Go like that. Cut that out. Then we'll undo a bunch of stuff we did. Undo. Mass undo. Yeah. We'll redo that. Okay. Now, put in our ifs, or massive if statements. And we'll do the thing that I don't want to do. Which is this. Wait, control. That. Yes. Copy that. Paste it here. Paste it here. Paste it here. Okay. So this is way uglier than what I planned, but it has the advantage of being simpler and thus less chance of me fucking it up, which I probably will do because I'm recording on camera. I'm trying to like explain shit sort of while I'm doing it. So we're doing it the simple but not as elegant way. Different loops depending on our state of movement here. So here we have what? Vx and Vy are both positive. So if we're moving to the right, we can keep our x list, our x loop the same way it is, but if we're moving upwards, we have to reverse our traversal here. So we'll have to do, less than or equal to, or greater than or equal to, minus minus. And we want to work from the bottom to the top. Seems right to me. So that's Vy greater than 0. Vx. Vy is less than 0. Moving down to the right, we leave these two loops are fine. Now, go down here. Again, Vy greater than 0, we have to switch this one, but if this one's not fine, we have to change our x. So x minus minus, because we're moving in the opposite direction. And we want greater than or equals. And I want to switch these around, the start and the end. And we'll cut this out here. Paste that here. And that, my friends, should be it after we fix this one here. Yep. Wait. Vy greater than 0, bottom, top, bottom, top, left, bottom, left. Yep, that should be it, if I'm not mistaken, which I might very well be mistaken. Now, for the do collision here, we need the sprite's velocities. So S dot, yeah. So we need to be able to get the velocity of the sprite. Don't like exposing any more than I have to, but it looks like I have to expose this. So, float get Vx const return core dot wait, let's do that. Dot Vx okay, why don't you like this now? Operand of blah must be pointer. Well, what's the problem with this then? Ugh, I don't even know what I'm doing anymore here. core.vx. Why is this one need? What is this for? Why? How do? Core is just a thing here. Can I get rid of this? Nope. All right, because its state is a... Okay, I get it now. State is a pointer. Whew. I just don't know how to program in C++. That's the problem. Just to remind myself of what I'm about here, putting those brackets in there. Okay, so now we're able to get the Vx and Vy out of sprite. Let's use this for the great justice. There. Now there's another way I could handle this situation, and I probably will do this later, maybe. But what I could do is I could we have rectf, right? Where is it? Just a simple floating rectangle with top, bottom, right, left. We could also add to this, we could subclass a new class called collision rectf and add to that velocity, because velocity will become important between, for example, two different sprites colliding together, because you need the velocities of both sprites in order to determine the relative velocity between them. So it might be useful to create a what do you call it? A collision rectangle class that also includes the velocity of the collision rectangle. And if we did that, where is it? If we did that, we wouldn't have to pass this and this, and we wouldn't have to add those accessors to the sprite class. We could keep that shit private, and all that useful information would be stored in the collision rectangle. I could do that, but I don't feel like doing that right now. I might do it later. Right now, I just want to get this bullshit done, because this is getting to be a pretty fucking long video. So let's see how bad it is now. Because I will not let myself hope that there's no bugs. Well, that's weird. We still have the problem, which is bad. And now we also have the problem going down. I think I know why, though, because I did the thing that I always do. I keep thinking that positive Vy means going up, but positive Vy is obviously going down. Fuck! So, let's go into tile map here. Ugh, look at this ugly, big, long function. I could make it nicer, but just I'm not feeling it right now, people. I'm just gonna switch the signs around because I don't want to copy and paste a bunch of bullshit. So I fixed that by realizing that once again Cartesian coordinates have fucked with me. There we go. Now we are behaving in the manner in which we intend to behave. Now I shouldn't be bumping my head, like getting caught on the top here when I jump, and I'm not. Smooth sailing. Yeah. And this one is fine too. This is fine. Fine and dandy. I love it. You love it. You know you love it. You know you love it. I'm going to do a little bit more testing here. In the playgrounds of death here. Because here's where all the bugs can happen. Lots of corners and shit. But it looks pretty solid. I like it. I like it indeed. Okay, I think we're done. I think this has finally done it. Ugh, I hate this. But I'm not changing it because it works now. So, what is left for me to talk about? Well, there's one thing I want to say. And that is, remember when I said that the way we solve this is by changing the loop direction, looping this way or looping this way, looping to the bottom, looping to the top, whatever. Another way of fixing this problem is the problem exists because all of these tiles have their own individual collision lines here, collision boundaries, and I just cannot learn to change my layers. They all have their own individual collision boundaries, and so when our sprite moves, it can hit up against this one and then get pushed back or whatever. Or if it's jumping up, it can hit up against this one and get pushed down. Right. One way to solve that problem is to give, instead of having every sprite have its own collision boundaries, create... Ugh, this color sucks. I want this color. Create single line boundaries around the edges of all the sprites, or all the tiles, all the solid tiles. So you'd have like one line from here to here, one 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 from here to here, and then here to here. And those would be your 4 boundaries. And in that case, you can't get caught between... Ugh, I did it again, didn't I? I sure did. I'm going to use this one now. Fuck you guys. You can't get caught between, you know, two tiles and stuff. Because the boundaries aren't on an individual tile-by-tile basis. They're by the line. Now, you might say, that'll make level design a lot harder because now you've got to draw all the tiles and then draw the boundaries around the tiles. And if you change a tile but forget to change the boundary, you're going to fuck up your whole level. And that's true if you do it that way. If the user has to draw, if the level designer has to draw all the boundary lines manually, that'll be a problem. But you can do it the same way. You can have solid tiles and passable tiles. And what you do then is you make your tile map like that, and then when you load the tile map in, you use the solid and passable states to algorithmically generate your boundary lines. So you generate them on the fly as you load the level. Or you can pre-generate them as a step when you're compiling the level or whatever. It doesn't matter. The idea is that the designers only see solid and passable tiles, and the game engine only sees these lines here. And you can do that, and that would probably be a better solution than the one that I've done, but it's also more complicated. So I went for the simpler solution here. This is a better solution if you are interested in trying it yourself. You got to change a lot of stuff though if you do that, because you're changing the whole way your collision works. But it's a good solution. So that's one thing I wanted to say. Another thing is I want to do that thing that I said that I wasn't going to do, which is I want to create a collision RectF. So I guess I should create a new thing. Bleh. So I go project, add new item, H file, collision RectF. Now I don't think RectF actually had its own implementation file. I just made it all in the H file. So I'm going to do the same for collision RectF because I'm lazy. First I need to go here. No, I don't like that. Back. There we go. Pragma once # include RectF class collision rect F. Whoops. Whoops. Public rect F. There. Okay, now I need to implement a bunch of dumb bullshit that... Yeah, I think I need to implement bullshit here. So, collision rect F. Constant yes. Yes. There we go. Okay. Ugh. I don't like creating all these dumb, like, constructors and shit. It's boring. It's boring as hell. Top, r dot, top. Bottom, r dot, bottom. Left, r dot, left. Fuck you. Right, r dot, right. Let's go to rectf. Protected. I think I can do this. Rect F. Oh, now I gotta make sure it's the right order. It's top, bottom, left, right. Okay. I'm nothing if not predictable. Bottom, r dot, left, r dot, right. So that initializes the rect F part. What? Why don't you like that? Expected a colon. I have no idea. I don't even know anymore. Public. Collision rect F. Yeah, spell it right. Public rect F. Protected. Float. VX. Float VY. Now, why is it not letting me use the fucking rect F top, bottom, left, right? Public? Yeah, that's fine. Public rect F. I don't understand computers. Let's go to game. Go. Let's go. Collision rect F. Let's try to build this bullshit. Hey, turn the fucking heater off. Ugh. Sweating balls in here, man. Okay, what do you want? What do you want from me? Cannot access protected member. Keep doing dumb shit. Okay, let's fix that dumb shit right now. Where is rect F? Collision rect F. Public. I feel like this is the second time I've tried to make that private or protected or whatever. Failed. Okay, that makes sense. Where? Where's the error? There it is. Syntax error. RectF should be preceded by... Why? I must be doing something incredibly dumb, but I just... Oh. Okay, I was doing it dumb, but you weren't helping me any, fucking compiler, man. You were like fucking dancing on my grave or whatever. Okay. That is that. There we go. Float. There. And we go Vx, Vx, Vy, Vy. That was dumb. Why did I do that? R.vx. Stop it. R.vy. So that lets us copy one collision rect to another. What else? What else do we need? Initialize from values. Translate, it's fine. Draw, that's fine. That doesn't need to change. Okay. I think we got this under control. So we need one of these. Float. Go away, be gone. Away with you. Good. Okay. That's those two out of the way. What else do we need? Let's add one more. Oh, let's add two more. We'll add one of these. That was pointless. Put that there. And we'll add one like this. Except we'll use just a normal rectf. And then float Vx equal to 0.0f, float Vy equal to 0.0f. This is initializing a collision rect from a normal rect. That's fine, that's fine. Vx, Vy. Alright, so now we have all of our different constructors set up. We have our Vx and our Vy. And that's all we wanted, really. That is all we need. Now, we can use, well, first we'll build. Good. Now let's go to game. Let go. Get rid of that. Okay, so a sprite will return a collision rect F. So I guess we got to go to core, sprite core. And we'll go collision rect F. Return collision rect F. Collision rect F rect. C rect. Core.vx, core.vy. core is unidentified. Oh yeah, because we are core. We don't need core, we are the core. Then we translate this and we return it. And that should be fine. Now, who needs to handle this bullshit? I believe where is a dumb thing? Tile map. Tile map. Get crect single. Get a list. Collision rectf. I'm going to make that a reference. Yeah? Yeah, it's fine. This one has to be collision rect. See, I can pass it a reference because it's a reference to rectf, because collision rectf derives from rectf. So if it's passing by reference, I can pass the derived class as the parent. Now this one, I want to pass it as the derived one because I need the access to the velocities. So we'll do that. Ugh, this is bad. This should be rect out because it's the output rectangle, I think. Ugh, that was really bad naming there. I gotta change that. Anyways, get crect single. Ugh, now I can't do collision, do support. Okay, we'll do one of those. Do. There we go. Now, collision rectf. How do you like that? Okay, we got to get rid of these ones because we don't need them anymore. Now we do crect dot vx. crect dot vy. crect dot vy, and that's that. There you go. You like it. You know you like it. Now this one should be rect out. Out. Rect out. Rect out. And rect out. Alright, how's that? It's probably still not good enough, but I think we're getting there. Yeah, I think I saw some nasty stuff here. Cannot convert. Okay. Let's go to tile map. Get rid of that. That should solve some problem. Failed. Where's our next problem? Get crect list. Aha. This one needs to be like that. Build. Still failing. Where? Unable to recover. crect single does not take 4 arguments. That it does not. Doesn't take these ones. Now what is your problem? Initial value must be an L value. That looks like an annoying error. Listen, get crect. Go to declaration. Must return a collision. Am I correct? Looks good to me. Alright. So now the rectangles that we get from our sprite core are collision rectangles. They have velocity. The other ones don't have velocity, but it shouldn't matter. Get C-rect. I could turn these ones into C-rects as well later on. I might do that with just zero velocity, because they are collision rectangles. They just don't have any velocity. The question is, did this break anything? Shouldn't have changed a damn thing. It's just a background kind of behind the scenes implementation detail. And it looks like it hasn't changed a damn thing. It's fine. Yeah, it looks good to me. So that was the last thing. Just something I wanted to do because I like it. That is a collision rect F. Right here. Just adding the VX and the VY in there. And where does that come out? It comes out of Sprite and Sprite Core. Where does it go in game? In game.go. Nothing, because the sprite is passed directly to the do collision and do support. So we go to do collision. Here. And we just call get C-rect single. Do support. Interesting. This should be a collision rect F. Get tile passable. Interesting. Yeah. Get C-rect single. Rect out. And rect out is a normal rect F. So we create a normal rect F, we get the rect out, and we do on collision, which takes a normal rect F. So we should probably in the future change on collision to take a collision rect, and change get C-rect here for tile to give a collision rect. Because when we go between collision between different sprites, we're going to have to use C-rects all around collision rectangles. So, yeah, let's do that right now, because I'm going to forget if I don't do it right now. And this video is already way too long, so who cares? Turn that into a collision rect. Oh, wait a minute. Scratch that. Go to definition. Wait. Go to definition. What? Oh, wait. This is the definition. Never mind. It's an empty function right here. Ha. Okay, so that was on collision for this one. Now we got to do it for player moving horizontally. This one we can do it. Yeah. Collision rect. Now we go back. Collision rect F. Now we go to player jumping. Where's our stuff here? On collision. Go to definition. Collision. Ugh, we also want this one to be a collision rect. We basically don't want to use any rect Fs anymore. Collision rect F. You know what I should just do? No. I can't replace all of them. As much as I would like to, I can't do it. Because there's a couple places where I just want a normal rectf. Like, for example, in the core, when we have our static rectangle that we translate, that doesn't have velocity or anything. That's just a normal static rectangle. We don't want that one to be collision rectf. Alright, so there is all of our stuff. Let's build that, see if we get any errors. It seems to have worked. So we go to tile map, do collision. Make this one a collision rect. F. It's weird though that it would accept a normal rectf when on collision here is asking for a collision. I don't understand that. I almost think like my compiler isn't compiling the right code. But yeah, we do that. We make that a collision rect. We get C rect single. Get C rect list, get C rect single, is already taking a collision, is returning a normal rectf. We want it to return a collision. Go to tile map. Yeah, that is kind of strange that it is accepting normal collision rectangles in all these weird places, when it should be demanding that it's go to definition here. So now tile get crect should return, yeah. I'm interested here in what happens. Rect out. Let's build this. I'll bet this uses one of the constructors that I've made, but I'm not sure. So I am going to debug. Actually, I want to put another one on my collision rectf. I think it's going to use this constructor to turn a normal rectf into a collision rect. Create a little dummy line here that does nothing. And we will compile and run. Okay, well, that doesn't matter. Oh, I might have to stop here every single time I... How many... Why am I doing this? Okay, this is a problem. Fuck it. Go. Okay, now if I collide with something... Where is it being called from? Get C rect. Collision rectf. Ah, it's being called right here. Okay, that makes sense. Well then, fuck you. Let's go back. Take that off. We'll go. Okay, now if I bump into something, bam. Wait, what? There we go. Get C-rect single. Ah, okay, I only put it on this one here. So what I want to do is, we have rect out. I jump in. Get C-rect. Jump in. And where, yeah, I did go to this one. So when I use the equal sign, it actually uses this constructor. Interesting. Interesting indeed. So that is why, I'm sure nobody wanted to know this but me, but that is why that this return thing works here. It's converting this into this using the constructor that I made for that purpose. However, I guess I can leave it the way it is then. I'll let this one return a normal rectf and let it get converted into a collision rectf through this assignment. I'm sure this will be shooting myself in the foot sometime in the future, but whatever. So I think I'm happy with all that now. Collision rectf, takes this collision rect, converts normal rectf into collision rect. Good. Then uses the collision rectf on the on-collision event here. I think we're done. I think I am finally satisfied with what we have here. So that's collision in a nutshell. I don't know. What do you think of it? How do you like? Leave your comments on the forum, I guess, or whatever. The next thing we're going to be doing is we're going to be doing scrolling and cameras and viewports. So we're going to have we're going to make it so that the environment can be larger than a single screen, and the camera will follow the player as he runs through the level, and it'll also properly handle the clipping of objects as they are like half off the screen or whatever. Culling, I guess you would call it. So yeah, that's the next step. But this was collision. Like I said, it was going to be long, and it was long. And now I've got a ton-ass of editing to do, because there's a bunch of stuff I have to cut out and recut and cut in. Well, next time we're going to be doing scrolling. Enjoy and toodaloo.